And I'm going to get 26.6 degrees. So with the protractor, so this orientation is our position. So the 26.6 degrees, right, is from here. Because it is positive, so this is 26.6 degrees. Okay. So anything that is above, as we know, okay, anything that is above the neutral axis, okay, any point on top will be in compression. And then anything below, okay, will be tensile. Okay. Now let's look at another example. Okay. Let's look at another example. And we are going to apply the rules that we have learned. Okay, the rules that we have learned. Okay, so let's look at, and it's a very short example. Okay, so example number 2. Okay, so example number 2. So if you can get this figure on Avenue to Learn. Okay. Okay, so this is where things get a bit confusing. Okay. Okay, but I'm going to unconfuse you. Okay, so for this question over here, it's pretty straightforward. So we're going to find the orientation of the neutral axis. Okay. Okay. So now the formula that we are given is tangent pi is equal to tangent theta, right? Then IZZ over IYY. Okay. Okay. IZZ over IY. So now if you look at this orientation over here, right? Our y prime is in this orientation. And then our z prime is this orientation. This is just confusing us. Okay, it's just confusing us. So whatever we do, okay, whatever we do, right? This axis, y prime and z prime, okay, on this formula, right? If I were to rewrite this formula, right, this is in fact IZZ prime and IYY prime. Some of you say, Eugene, why is that? When we derive this formula, right, when we derive this expression, what did I tell you? Right? What did I tell you when we derive this expression? That the transformation rotate with the what? With the structure. Okay. So when it's moving off the x and y, they call it what? Z prime and y prime. Okay. Now, why did they do that? The thing is, why did they do that? Okay. And they did that is because to make our life simple, right? When we do that, it's easy to find, right? It's easy to find the second moment of area about y prime and the second moment of area about z prime, rather than try to find the second moment of area about y and z in this orientation. Look, most of you, your math are better than mine. I will tell you that. You can do it. I know that. Okay. But I don't want to make our life difficult. Okay. So we are going to use the values of iy prime and z prime over here. And it's always easier to find, right, the second moment of area about y prime than z prime, rather than finding iy and iz. Am I right to say that? Okay. So when that's the case, okay, we know that everything rotates from the z-axis. Okay, so this axis over here controls the. Let me choose a different color. Okay, this axis over here controls the orientation of the of the uh, of the magnitude of the moment and the position of the neutral axis. If we're going to apply this formula over here, get this straight, okay? If you don't get this right, it can get very, very confusing. Okay. Any questions so far? Okay. So let me demonstrate how easy is this. Okay, then probably that will answer your confusion. Okay, so we want to find theta. Okay, so theta is measured from the z-axis. Okay, so this is theta. Okay, and theta down here we know is 45 degrees. Now it's going anti-clockwise, so it's minus 45 degrees. Is going anti-clockwise. That is the most difficult thing. Other than that, everything is easy. Okay, so you have tangent pi is equal to tangent minus 45. Okay. Izz prime is equal to 21.4. Then divide by 6.74. Okay, so pi is equal to 21.4 divided by 6.74 multiplied by minus 45 tangent of minus 45, and then inverse tangent, I get minus 72.5 degrees. Okay, so what does 72.5 degrees means? It means that the rotation from the z-axis, okay, from z prime axis, will be in the anti-clockwise direction. Okay, so 72.5, I'm going to eyeball this. Not eyeball, I'm using a protractor now. So 72.5. Somewhere around here. Okay, so this is the orientation of your neutral axis. Okay, and the 72.5 is measured from here to here. So this is the 72.5 degrees. Okay, so be very clear about this. A lot of times students are confused. Now, what if the question were to ask, okay, let's say I throw another monkey wrench at you, okay? So let's say we have the orientation. I want you to find the orientation. Okay, orientation of neutral axis from horizontal. Okay, from the horizontal now. Okay, so from the horizontal, I'm going to draw the horizontal. horizontal axis. Okay, horizontal. So horizontal, it means everything is flat. So this is where the horizontal is. I will use orange now. Okay, so this is our horizontal plane. Okay, that's our horizontal plane. So what is the angle then? Okay, so the angle, okay, so the angle orientation will be equal to minus 72.5 plus by 45. Okay, because the horizontal plane relative to Z prime is 45 degrees. So this will be equal to minus 22.5 degrees. Okay, so if you are confused about 22.5 degrees, okay, so you just need to tell me the orientation is going in a anti-clockwise direction. Okay, so sorry, you can put it as minus 22.5 or 22.5 degrees in the anti-clockwise direction. So this is the angle we are talking about from. So this is our 22.5 degrees. Okay, so nothing too difficult at all. Are we clear? Any questions so far from anyone?
Hey, Eugene, I got a question. Oh, sorry, you go first.
Oh,
Yes.
I was just going to point out that it should be 27.5.
Is it 27? Oh yeah, you're right. I'm always sleeping, you know. Thank you.
No worries.
1 pint of beer, okay? Thank you. Anyone, any other question, please?
Yeah. Hey, Eugene.
Yeah.
How do we know like theta was going like clockwise and not counterclockwise, like
Because everything is from the z-axis.
z-axis?
Okay, everything is from the z-axis down here.
Oh, okay.
Okay, and the z-axis is attached to the what? To the structure, not attached to free space. Okay, so that is why over here, for this question over here, the z-axis is z prime. Okay.
Yeah.
On the global z-axis is this orientation over here. Do not follow this orientation, but follow the orientation that is attached to your structure.
Okay.
And the reason why is because it's easier to find IY prime and IZ prime rather than to find IY and IZ for that simple reason. Okay.
Okay. Thank you.
I mean, this is the part where a lot of students get it wrong. Okay. So is the angle always from the z-axis? Yes, the z-axis that is attached to your structure. Okay. Hamraj. Okay. And how do you know how to position the neutral axis on that angle each time? Kind of confusing. It's not confusing at all. Okay. Okay. Sorry. Hamraj, I cannot tell you it's not confusing at all. If you have a structure that is in this orientation, it is very obvious to call this Y and to call this Z, right? Now, if you have an orientation tilted in this direction, right, it's easier for us to find Y prime and Z prime. It's easier for us to find IYY prime and IZZ prime. Am I right? Hamraj, does that answer your question over there in terms of the axis?
I'm not gonna lie, it did not. I'm still confused. Cause
Okay.
like,
Yep.
I'm just confused how cause like in the last example you positioned it differently. So I'm just trying to figure out how you just like draw it and it's like that's neutral axis. You know what I'm
Okay.
saying?
So you're talking about the Y and Z axis, am I right?
No, like the green neutral axis that you draw.
Oh, the green neutral axis. Okay.
Yeah.
The green neutral axis is from the Z prime axis. Okay. Why is that? When we derive this formula, right? The neutral axis is measured from where? From Z. And this Z is attached to your what? To your structure. Okay, so the confusing part is down here is known as Z prime. Right down here is known as your Z prime. Why do we use this Z prime? Okay, what did I mention earlier? The axis Y and Z. Okay, when we went to the previous, not previous, but when we talk about this, what I highlight this. Z and Y, this axis is always attached to your what? To your structure. So when you rotate it, it's known as Z prime and what? Y prime. Raj, does that make sense to you now?
That
Oh.
makes sense, but I'm still trying to, if you go down like to where you drew it, like
Yeah.
in that like to the example we were on.
Oh, hold on. I just crap out from one note again. This one, right?
Yeah. So when you tilt it,
I did not tilt it. The problem tilt that orientation. Okay, I did not tilt it. The Y prime and Z prime were given.
yeah.
Okay, I did not tilt it. But all